Alright, so this video is going to be a little bit shorter because solving linear equations requires that you do some things that we've already been using, and it is something that you should have already seen technically before Algebra 1. Now, most of the time, most Algebra 1 teachers do a little bit of review of it, so that's what we're doing here. We've already reviewed some of those steps of moving something from one side of an equation to another, and that typically involves us using addition or subtraction, if I can talk. Down at the bottom here, you'll see this little note says, remember, you always get rid of the terms by adding or subtracting. We also talked about recently when we were getting rid of a coefficient beside a variable. For instance, I'll give you a quick little example of what that looks like from what we talked about the other day. Moving something from one side to the other. Oh, let me get back to here. All right. Over here, we subtracted 2x, like I said. But when we were getting rid of the coefficient beside the y, the 3, we divided. Whenever you're getting rid of a coefficient, you always get rid of coefficients by multiplying or dividing. So that's two big important notes that you need to make sure you understand about solving equations. These other steps for solving equations that I have listed here on this screen are steps that help you get through some of the ugliest problems you'll see with one variable equations. When we deal with two variable equations, we solve those by getting points on a graph, and we're going to practice that before the end of this video also. I'm going to send this little steps for solving equations sheet out to you so you can use this and you can have it with you even while you take the test or the quiz. That's fine with me. So when you are dealing with steps for solving equations, this CLT that you see everywhere here stands for collect like terms. Most of us, when we're solving equations, are pretty comfortable when we see things that are 7, 8, and 9. What I mean by that is, if we have something like 2x plus 3 equals 9, and we have to remove the constant term by adding or subtracting, meaning we subtract 3 here, 9 minus 3 would be 6. Notice that's collecting like terms and collecting like terms. That's what CLT stands for. Then step 9, we remove the coefficient by multiplying or dividing. We divide by 2, we divide by 2, and we get x is 3. Most of us are pretty comfortable with steps 7, 8, and 9 when we're solving equations. When we get into things like step 5 up there that has a variable on both sides, or we have to do like step 3, we remove parentheses by distributing, or heaven forbid, step 1 up there where we have a bunch of fractions in the problem and we can multiply by the common denominator to get rid of all the fractions. If we have some of those other problems, the biggest thing I can tell you is try to get your variables to one side, like this 2x plus 3 equals 9 that we have. Get your variables to one side, then get your numbers to the other side, like we did subtracting 3, and then we divide by 2. Essentially, you can take all these steps 1 through 6 up here and you can boil them down into simplify the problem down to something like this. Something that's 2x plus 3 equals 9. You can boil it down to make the variable get by itself. And so sometimes I'm going to have to move stuff around. Sometimes I'm going to have to multiply everything in the problem. It just depends on what the equation is. So what we're going to do, like I said, is this going to be a pretty quick video. We're going to go through just a couple of examples of a little bit uglier equations. I'm going to start with one that's kind of got a few fractions in it. 1/3 x plus 2/3 equals 9 over 6. Now, I know 9 over 6 can be simplified, but notice you've got 3 for the denominator, 3 for the denominator, 6 for the denominator. What's the common denominator for all three of them? 6, meaning you can multiply this whole equation by 6. This is what step number 1 says, and it cancels out everything. So 6 times 1/3. I'm going to show you what that looks like in the calculator. So I'm going to go to my calculator and I'm going to go 6, and I'm going to do parentheses, 1 divided by 3 in parentheses, and you can see that it gives me 2. In other words, 6 times 1/3 is 2x. So that gets rid of the fraction for me. 6 times 2/3, I'd go to my calculator again, I would get 4. 6 times 9/6 would end up being 9 because the 6's would cancel. Now I'm at an equation where it's fairly simple. I subtract 4 on both sides, collect like terms here, gives me 5, divide by 2, and I get x is equal 5/2. And this is solving a linear equation. Now some of you may be thinking, wait a minute, Mr. Harrison, that's not a line anymore. It is still a linear equation because it is a variable raised to the first power. What you're thinking of is when we have an x and a y we got to solve for, that's where graphing the line actually comes into play. So let's do a couple of others. Let's say you have something like 2 times x plus 3 plus 4x equals 6x minus 7. And I just made this one up, but this is the kind of thing that you're going to have to do when you are dealing with, let me go back here, sorry. This is what happens when you make something up. Let's go with 8x here. This is the thing you're going to have to do when you have to make your little Flipgrid video and you have to make your own equation and solve it. You got to have all these types of things, distributing or collecting like terms, variables on both sides. And so when you go through, you would just tell somebody step by step how you would get the x by itself. So first you would multiply 2 times x. Then you would do 2 times 3. But now you have plus 4x. Now here's where I need you to be careful here. We have this rule when we're solving equations that what you do to one side, you got to do to the other. The problem is this 2x was already here with this 4x. So when you do 2x plus 4x, that is 6x. It's like $2 plus $4. But those two things were already on the same side. You didn't do it. They were already there. Now, when you make your own problem, you still have to think of that way. You have to think, hey, those 2x and 4x that are on the same side were already together. If I was setting up a real world problem and that happened, they were already together. Don't do it on both sides. What we mean by what you do to one side, you got to do to the other is when we look at this and say, okay, I want to move this 6x over here to get the x's together. I typically, when I have a variable on both sides, move the smaller one, meaning I'm going to subtract 6x. That is when I also subtract 6x on the other side. What you do to one side, you got to do to the other when you put something in the problem that wasn't there before. So these cancel out, leaves me with 6. 8x minus 6x is 2x, and then I have this minus 7 over here. But then once I get to here, most people are pretty good. This is that 7, 8, 9 step on that steps sheet that I gave you. If you add 7 here, you add 7 here. Again, what you do to one side, you got to do to the other because the plus 7 wasn't there before. You put it there. That's what you got to think on that rule. If you add 7 and 6, you get 13. You divide by 2. You divide by 2. 13 over 2, or 13 halves. If you need a decimal, you could take out your calculator and do 13 divided by 2. And if you do 13 divided by 2, it gives you 6.5. Again, your calculator, if you hit this little fraction button, will change it back to a fraction for you. That fraction is there to help you out if you need an exact answer. This one is kind of pretty though. It's 6.5. That's not too bad. But make sure that if you use a decimal, it makes sense in the problem. If you use a fraction, make sure it makes sense with what you're talking about. If you're talking about a random equation like this, it's not a big deal if you use a fraction or a decimal. So this is how you get that x by itself. Now, yes, there are smaller problems. There are real easy problems like we did with our x-intercept, y-intercept the other day when we had 3x equals 6. You just divide by 3, you get x equals 2. There's going to be quick problems like that. There's going to be some times where you have x minus 4 equals 10, and all you got to do is add 4 to get 14. There's going to be times when the equation is real quick, real simple. Other times where you have to do a lot of work here to get x by itself. But the ultimate goal is to get that x by itself by moving things around, getting the x's together, making sure you distribute if you've got distributive property, make sure you collect like terms if you can collect like terms. So the only other thing I want to point out about solving is what we talked about the other day, specifically with graphing. We said that when we have a graph, it is the solutions to the equation. Well, I wanted to give you kind of an example of actually doing that in a problem. If you have this example of fundraising for a zoo, and I know I used a fundraising example the other day for a school thing with hats and t-shirts. This is the same kind of concept. You're organizing the annual spaghetti dinner to raise funds for the zoo. Your goal is to sell $1,500 worth of tickets. Assuming 200 adults and 100 students will attend the dinner, how much, this is the key, you don't know this, how much should you charge for an adult ticket and for a student ticket? Those are the two things that I don't know. That's my x and my y. What are the things that I do know? I do know 200 adults are coming and 100 students are coming to it. Now, I did assume this because this is the annual spaghetti dinner. So I've probably done this before. I know a lot of you plan out your spaghetti fundraisers, right? But I know that I also want to sell $1,500. Now, if I sell more, it's okay. But my goal is to have 200 adults times whatever I charge them, plus 100 students times whatever I charge them, equal to $1,500. Again, if I end up with more, that's okay, but I'm just trying to set a price to start. Notice this equation has an x and a y, not just an x like the ones we just practiced. So when you have an equation that has an x and a y, this is when that whole concept of graphing the line comes into play. What I'm going to use is I'm going to use our x-intercept like we did the other day, because that's a good way to do problems that look like this. It's also a good review for you. So I'm going to plug in 0 for y, because on the x-axis, that's what y is. This gives me 200x equals 1,500. I divide by 200, and x is equal to 1,500 divided by 200 is 7.5. I'm okay with that being a decimal. That's my x value. My y value is 0. And so that would give me a point on the graph at 7.5. So I'm going to go over here to 7.5 and 0. And I know I kind of made my point a little fat there, but 1, 2, 3, 4, 5, 6, 7.5 and 0. That would be the x-intercept. The y-intercept, remember, we let x equal 0 because that is going to be the value for x everywhere on the y-axis. So we get 100y equals 1,500. We divide by 100, and that gives me y is equal to 1,500 divided by 100 is 15. So that means 0 for x. We plugged in 0 for x. The pen's freezing up on me again. 0 for x. We got 15 for y. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me make sure I did that right here in just a second. We'll count that again. Once the pen starts working again. I don't know why this thing doesn't like me sometimes. Oh yeah, that's great. Now what's it doing? Quit it. Okay. Now that we got that out of the way, those 2 points are solutions to the equation, and they are points on the line for this equation. Now I want to talk about something too. Notice that I only drew what we call the first quadrant. Why did I only draw the first quadrant? Because I don't need negative numbers for x and y. Remember, negative numbers doesn't make sense. I'm talking about the price for an adult ticket and the price for a student ticket. I don't want to do negatives. That would be like me standing at the door for my fundraiser and handing out money. That's what we call DUMB. Dumb. We're trying to make money, so we're selling tickets for money. What do these points actually represent on this particular graph? Well, let's talk about this guy. 0, 15 is the one that I like the most. Why do you like that one the most, Mr. Harrison? Well, think about it. 0 for X, 15 for Y. 0 for adults, 15 for students. I get to eat free. You don't. I know, that's mean, isn't it? Now, some of you are thinking, oh, okay, I get it, Mr. Harrison. I like this one the best, because 7.5 and 0, that means adults pay $7.50 and students pay nothing. We get to eat free. In college, that's what they will do to you. They will give you free food to just try to get you to go to places you don't want to go and go to meetings you don't really want to be at. They'll offer free pizza. So these 2 points are sort of the extremes. This is where I charge all the adults and no students. This is where I charge all the students and no adults. In real life, we're probably going to be closer to somewhere right here, actually. This is probably going to be the real life solution. That's 6 and then 3. 6 for adults, 3 for students. The adults pay more. Students pay about half as much. That's pretty, status quo for what most people do, in the real world. Some people who are into equality may say, Mr. Harrison, you're a jerk. I'm going to put it right here. That is 5, 5. That is 5 for students and 5 for adults. Everybody pays the even amount. Now, I don't know why I'm using that voice, but guys, that's a solution. Remember what we said. Every point on the line is a solution. So when you are tasked with solving equations that only have one variable, when you are tasked with finding equations that only have one variable, all you got to do is get that variable by itself and your solution staring you in the face. But when you are tasked with finding solutions for 2 variables, like how much do I charge adults and how much do I charge students in this case, I could have multiple answers for this. The only time I'm not going to have multiple answers for this is what we'll look at actually in the next chapter, so to speak, the second half of this linear module. You're going to do some discussion about that, but I just wanted to kind of introduce that here. You're going to be talking about times where you may have more than one equation at the same time. So one equation like this with x and y, the points on the line are solutions to that equation. Make sure they make sense, positives for this particular case because we're talking about money. And make sure that they actually make real world sense. You're not going to charge students $15 and adults nothing. But technically that is still a solution because every point on the line is a solution. So when you have one variable, solve it by getting x by itself. When you have 2 variables, go through and take this and solve it by getting the graph of the line.